Tuh hilang malah Mas Bambangnya Bu Dini.
Oh iya.
Putus ya kayaknya.
Oh iya, terputus sepertinya.
Ya, ditunggu nggih rekan-rekan semua.
I just messaged Bang Bang. I think the Zoom restarted.
Oh, okay, Mr. Rian.
Yes, start. Maybe you can start, Mr. Rian. If
No.
Can
you hear me now?
Yeah.
Yes, yeah.
Okay, sorry. Because so many messages from Zoom in my side, sorry. So I think I clicked the wrong option. So okay, I think I would like to share about the agenda before we continue to Ian. So wait, yeah. Okay. Untuk Pak Fuad dan Budi bisa lihat screen saya sekarang?
Sudah, Pak.
Oke, siap. Jadi bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang untuk rekan-rekan dari ITS. Jadi sebelumnya saya ucapkan terima kasih untuk Bu Dini dan Pak Fuad yang sudah membantu saya hingga terlaksananya acara ini dengan baik seperti itu. Nah, mungkin untuk acara ini kita akan coba langsung saja. Saya di sini mungkin mau sedikit perkenalan dulu karena mungkin tadi Pak Fuad sudah sempat kita kenalan dikit-dikit ya Pak Fuad. Jadi mungkin sebelumnya saya hanya kenal dengan Bu Dini nih. Jadi ini untuk sesi ini saya kenal tambah teman baru di ITS yaitu Pak Fuad. Kembali perkenalkan saya dengan Bambang Nugroho. Saya untuk akun manajer di TechSource dan kebetulan untuk mewakili produk Network yaitu MATLAB dan Simulink untuk di Indonesia seperti itu. Nah, mungkin di sini saya mau sedikit menginformasikan kembali untuk mengenai apa itu TechSource karena mungkin sebetulnya yang tadi Pak Fuad sempat bicara, ITS sendiri udah customer MATLAB sejak 2017 kalau nggak salah Pak Fuad ya. Cuman memang baru per tahun lalu menjadi salah satu champion produk kita, Campus White License yang khusus untuk edukasi, yang mungkin sangat banyak kelebihannya. Salah satunya mungkin yang sudah dirasakan oleh ITS adalah untuk Campus White License mereka men-share semua produk Network seperti itu ya. Jadi untuk salah satu solusi yang mungkin kita share hari ini dengan Mr. Ian, salah satu solusinya adalah robotik, itu sudah dalam di cover produk Campus White License. Jadi untuk teman-teman di sini untuk mahasiswa atau mahasiswi yang saat ini sedang belajar robotik dan bisa mengakses produk MATLAB dari kami, itu monggo nanti mungkin bisa dilihat step by step-nya dari Mr. Ian untuk kemudian bisa diimplementasikan seperti itu. Oke, di sini saya singkat saja bahwa kita memang sudah cukup lama Pak dari 1996 sebagai distributor network, jadi mungkin kurang lebih sekitar 25 tahun. Dan selain kita untuk sebagai distributor, kita juga merupakan training. Kita menyediakan training untuk produk MATLAB. Nah, ini salah satu yang kita bisa tunjukkan bahwa kita cukup mumpuni untuk menguasai produk-produk MATLAB seperti itu. Nah, Texas sendiri kita ada di beberapa negara, ada di Singapura. Ini Singapura merupakan headquarter kita. Kemudian juga ada di Malaysia, Thailand, Vietnam, dan juga Filipina. Nah, mungkin langsung timbul pertanyaan nih, kok di Indonesia nggak ada ya Pak? Kebetulan di Indonesia tidak ada office-nya Pak, jadi office saya dari kamar. Saya mengikuti arahan pemerintah, jadi harus stay at home Pak, jadi nggak kemana-mana, kerjanya dari rumah gitu. Oke, jadi untuk saat ini memang belum ada kantor di Indonesia, mudah-mudahan setelah beberapa tahun MATLAB makin berkembang di Indonesia, mudah-mudahan ada kantor di Indonesia, seperti itu, amin. Oke, kita lanjutkan. Jadi untuk teman-teman yang mau pengen tahu lebih jauh mengenai produk TechSource ataupun apa saja yang bisa kami tawarkan, nanti mungkin bisa mengunjungi website kami, bisa ke Facebook kami, bisa juga ke LinkedIn atau mungkin ke YouTube. Nah, ini bagian YouTube yang saya paling suka. Mungkin jangan lupa teman-teman nanti di like, share, and subscribe supaya terus update nih produk-produk kita seperti itu. Oke, nah ini kita langsung aja ke agendanya. Untuk agenda kita kali ini mungkin ini sesuai dengan informasi yang sudah diinformasikan oleh Ibu Dini. Jadi kita akan membagi 3 sesi untuk robotik ini. Jadi untuk hari ini dan kemudian nanti tanggal 24 dan juga tanggal 31 Maret seperti itu. Nah, untuk speakernya di sini mungkin sudah ada diwakili dari tim kami dari TechSource, yaitu Mr. Ian. Welcome, Ian. Ya, Mr. Ian adalah Application Engineering Manager kami. Jadi mungkin dia sudah cukup pengalaman untuk di produk MATLAB, jadi mungkin ada beberapa informasi yang nanti bisa kita dapatkan dan mungkin bisa menjadi pengetahuan baru untuk kita semua. Seperti itu. Jadi mungkin tanpa panjang lebar, I think Ian, it's time for you to share about the first agenda in this webinar. Thank you, everyone.
Yeah, thanks, Bang Bang. So
Okay,
let me share my screen.
Yeah, I will stop my screen.
Okay.
Okay.
So just to give you a background, I'll be talking in English, but if you do have a question, please just place it in the chat window and I'll ask Bang Bang to translate it for me so that I can answer. But since this is still a recorded event, right, so you can probably still look back and go through the whole robot series. So we're still at episode 1. But what I'm going to do is use my presentation slide. Right, so a brief introduction about myself. I'm actually a software developer last time. So, but I'm not a traditional software developer, but I did a lot of software development for automotive safety critical systems. So it means to say that whatever you're trying to develop in an automotive setting is something is synonymous to MATLAB and Simulink. So one of the platform or one of the softwares that you would use in software development for automotive or autonomous driving would be MATLAB and Simulink. So here today, what we're going to talk about is more about modeling physics systems, right? Because we're not just controlling a very simple, plant model, but we're going to actually control a very dynamic kind of system. So we'll go through different types of modeling in terms of MATLAB and Simulink, how to bring in a kinematics model and motion models of a certain phenomena. We'll go through it, like what's the best option for you to use. Okay, so the episode right now is more about platform. So we think about the vehicle that we're going to model. Right now, I'm going to probably do something with a ground vehicle, but in the future, if you do have time, you can investigate further. How can I create a UAV, a drone, a underwater vehicle, a surface vehicle, a barge, whatever it is, as long as you understand the kinematics and the motion models of that particular system, is something that you can actually mathematically have a digital representation in MATLAB or Simulink. So do join as well in the next episode, which is like middleware ROS, because ROS is actually a very popular communication platform for robotics, right? So majority of your robot manufacturer like KUKA, Kinova, Universal Robots, ground vehicles, DJI in some sense, are likely to have a ROS piece of their software. So you can actually control and get some sensors and monitor some sensors using or utilizing ROS. And now the direction for ROS is that people are using it for, like, if you're familiar, it's actually used in Carla for autonomous driving. In Unity as well, ROS is actually one of the platform wherein you can communicate and control 3D simulation environment. So I'm actually writing here Carla, Unity. There's also Gazebo, which is likely will be used for simulation environments, and one way to communicate with them is through ROS, or robotic operating system. The next episode, right after ROS, will be more towards the application. So it means to say you have the plant models, Now you get the sensors, or you can control the sensor, control the motors. The next thing that you want to do is build your application. It might be obstacle detection or obstacle avoidance. It might be going from point A to point B, or any other things that you want your robot to do, right? And this is where navigation comes in. So there's a lot of topics that we'll go through with this series. But the first thing that we need to go through is actually the platform, right? We want to understand how we can control, how we can build, how we can get sensors from a particular mathematical equation, right? So let's move on to the next slide. So generally speaking, all of these robotic systems, right, are becoming really, really complicated. So first things first, they really have, there's like two things now in the robotic space. One is actually cobots. So when we talk about cobots, that's like a robotic system that involves a human person within that particular field. So it means to say there's a human person within the space of the robot, and they need to work together. And in this kind of category, there's a lot of things to consider. There's like probably safety. There's probably complexity in terms of avoiding a human being, or deciding something for itself to be as safe as possible, right? And it becomes as complex as it is, right? So because like right now, your ground vehicle is connected to a how is it? Your ground vehicle is connected to a particular arm itself. Yeah, sorry. Let me just restart my PowerPoint. Give me a sec. All right. And in latest, like I created this slide like 1 year ago. And one thing that you will notice actually is that in here in Singapore, I'm actually based in Singapore. There's actually like a lot of hype. I'm not saying it's not about hype, but there's a lot of investments pouring into startups, to students organization or student competitions that involves how does it a robotic platform, right? You will notice like here is a AGV or ground vehicle. This one is also an AGV, a ground vehicle. This one is what we call as quadruple robot. So the walking dog robot are actually called quadruple in some sense. And one thing that you would notice is that they probably attach a lot of sensors, right? So here, let me just zoom in really close. You will notice this is actually a what we call as a LiDAR. I'm not saying LiDAR. It's actually a stereo camera. Okay. And then you might have like other sensors here for your, let's say, IR cam, your typical image camera, and so on and so forth. So there's like multiple sensors that this robot can have, but you need to understand what is going to be used for. So first things first, you need to do platform, right? And the platform here is basically what it is. Is it going to be a ground vehicle? Is it going to be a quadruple? Is it going to be a UAV? Is it going to be a surface vehicle? Is it going to be an underwater vehicle? All these things needs to have a motion models, right? Or kinematics models, because that's going to be our things that we want to control. This slide actually just tells you like an example earlier, right? The Boston Dynamics. This one's actually from Boston Dynamics. And if you go to their, let's say their website for their careers, one of the highlighted, software that generally they are looking for are people who has MATLAB and Simulink background. right? So there's like MATLAB here, there's MATLAB and Simulink, there's ROS, right? There's, as what I mentioned earlier, there's Gazebo, Unreal Engine, Unity. These are pretty much all the things that you might want to be familiar with if you want to go to like that particular space, right? Or in your future career as well. So I don't want to like tell you that, okay, you still need to actually have an idea about Python or C and C++, because everything that you're going to do later needs probably to be written in an implementation language. That's why you would always see still these terms, right? So if you want to go for FPGA, then you need to deploy that algorithm in Verilog or HDL. If it's going to be deployed in a microcontroller, then definitely you need to place your algorithm into a C and C++ environment as well. So MATLAB and Simulink here is really just a platform, but later we can actually convert this one to C and C++. Okay, but that's just to give you an idea like what the industry is actually looking for. But first of all, the question now is, let's say if you're going to build your own autonomous system, how do we create our system? So there's like multiple blocks here. So one probably is perception. Second one is decision and planning. There's control. There's sensing. I'm not saying everyone would know all these things at once, right? But each engineer would have a particular role and a particular activity. But let's say you're just a college student, you're a graduate student, or whatever it is, but you need to start first with the platform, right? You buy the platform. You need to get that platform. Like I remember last time when I was still like 10 years ago, when I was still probably a student, not 10, I said 12, 13 years ago when I was a student, I was creating my own, let's say, line follower robot, right? But I need to create a kinematics model of a AGV, how's it, a typical car-like robot, because I need to buy a platform. So in this case, first things first is really understand what platform are you going to get. Is it going to be a car-like, a bicycle-like, a drone, a fixed wing, a quadcopter, or whatever, right? You need to have that first perspective first. So in this topic, what we're going to focus on is actually more towards the platform. Then we'll talk about perception, sensing, and plan and decide later at the third episode. So in the space of simulation, right, there are actually three things that MATLAB can do or can import, right? So one is that you can actually do what we call as physical model. Second one is an abstract model. Third one is that you can actually just get an external robot model from the vendor itself. So the question now is, if I'm going to create a physical model, then you might need to have your model from, let's say, Solidworks, NX, let's say Onshape, or any CAD platform, and bring it to Simulink and simulate. Right, this is where your mechanical engineer is really, really good at, right? Creating different models in their CAD environment setting. But in a CAD environment, you cannot simulate kinematics model, right? It's really just create that assembly, build the necessary components, but you cannot pretty much, do kinematics modeling from there, right? The other things that you can do with Simulink is that you can bring in a kinematics model. So what I'm saying with a kinematics model is basically a equation form of the system. So if you think about a robot, right, what we want from a robot is really all about its pose and its orientation, because this is what we want to control. Right, so when we say pose and orientation, pose means to say, where am I in the 3D space? This is going to be your X, Y, and Z, right? Orientation probably is more towards like pitch, yaw, and roll. So pretty much you're trying to probably have a system that can move in free space, but has these properties. I move the motor 5 meters, then the robot will, let's say, move in 5 meters with a certain orientation, right? So just imagine what we're going to do is create an equation. So let's say F of velocity of motor 1, then velocity of motor 2. But the results of this is basically our pose and our orientation. I'm not going to give that the full equation here, but this is like what we want to do. The question now is, what is your F? All right. So this goes back to mathematical equations. I'm not saying it's a hard topic, but your fundamentals in calculus, algebra, and geometry and trigo would be very important here. Okay. So this is where actually you develop that kinematics model. And what MATLAB offers is that there are already ready-made blocks for common robots, right? You would see here that there is an Ackermann kinematic model. That's probably a car, similar to a car setup, a bicycle kinematic model, a differential drive. This is actually our example later. And then a unicycle. The third one is basically you have a gazebo model. So when I say gazebo, it's actually a third-party simulator, but majority of your robots makers, when we say robot maker, right, like Kinova, Kuka, Universal Robot, or any vendors of robots in a commercial space normally have a gazebo model of their robots, right? So if you think about kinematics model, you try to really go back and solve the kinematics equation. So you need to really study back your trigo, algebra, calculus, and advanced mathematics in some sense, right? But later, I'll give you an idea later how to solve a very simple equation for the differential drive kinematics. Okay. So I'm going to go for first physical modeling, right? So normally when you have a physical model, you start with Solidworks or any CAD design. But the nice thing about MATLAB and Simulink is that we do have a capability to bring in CAD design directly to MATLAB and Simulink. My one thing that I really like about this workflow is that when you build your model, right, in CAD, this already gives in the properties of your weight, the inertia required to move a particular object, the type of material that you use. We're not just bringing in the property of like, I have a box and this is its kinematics models, right? What we're doing here is that you have the design of the robot itself in a CAD environment, which has already its, let's say, properties in terms of weight, material, and so on and so forth. Then we can bring that information to our simulation. So when you think about these kinds of models, it's really like you are going to build for a certain application already. Like, let's say, autonomous driving vehicles, right? When you create a vehicle model, the dynamics of the vehicle models, there's a lot of things involved, like suspension system, the type of tires, the rolling resistance of your tires, how many wheels are in the rear axle, how many wheels in the front axle, and so on and so forth. Because later, if you simulate a vehicle similarly to a box, right, the dynamics would be very different, right? That's why when you see some startups, when they develop a model, it's not as comprehensive as a model that Toyota made or Honda made or mature OEMs is building their vehicle models. Because again, it's a bit complicated to really create a mathematical model of an actual vehicle. right? But in this case, we just say, okay, I have a CAD design. I want to bring it to Simulink. So generally speaking, for SolidWorks or any popular CAD design software, we can actually just bring it to MATLAB and Simulink. So this is just a very simple use case, right? We prepare the CAD model. We then say, okay, I'm going to export. So you would notice in SolidWorks, there's just an export tab here. Then we just generate the sim mechanics. So this is the old name for Simulink, Simscape multi-body. Right, so you export, you get all these STL files. So if you're familiar with, let's say, if you're familiar with STL, basically that's your CAD design already, right? There's just something wrong with my PowerPoint today, that it keeps on restarting. Maybe I don't need to put it in full screen mode. Right. So once you have all these STL files, the next thing you want to do is you go to your MATLAB environment. And from here, we just need to actually tell MATLAB that I already have an STL file and use the function SimImport. So once you have the sim import, I am just going to get this XML file and press an enter button. So normally the XML is actually just the mapping of how all these STLs are connected, right? And once it's there, you will get a Simulink environment of that connected parts. So when I press the play button here in Simulink, you will notice that I have this model already. Right, in Simulink perspective, not in CAD, but in Simulink perspective. So I can move it around. I can actually add some some movements and so on and so forth. But what we're trying to do here is bring in models to Simulink so that we can actually add in some blocks that is necessary for us to build the robot physical model, right? So if I have the model now, I need to verify my system, right? So since I have the CAD model already, the next thing that I want to do here is, let me increase the size. The next thing I want to do here is just verify some behaviors or characteristics of the system. So you would notice actually the caster wheel, this wheel is actually moving without any actuation. And this is due actually to the different setting of the gravity. So here I just say, okay, maybe I have, when we try to import it from SolidWorks, there's some discrepancies on where gravity is being associated. So I just, in here in the video, I just say, okay, maybe it's going to be in this axis. Then I click apply, click OK. And when I simulate it again, I should not see any movements at all already, right? And here you will notice it's not anymore moving, okay? All right, so next one is I want to turn the wheels, right? So because I know that this is wheel number 1 and wheel number 2, how do I tell MATLAB that I have a motor attached to this wheel? Or I have a torque source or a command from a motor to turn 50 RPM, 20 RPM, 10 RPM, right? So the nice thing about MATLAB is that since I already have these joints, right, revolute joints, this is actually coming from the design that you have in CAD saying that this is jointly attached with a revolute joint to the main body. So means to say there is probably a bearing, a motor, a servo motor that allows it to turn on that particular joint, right? So if I just go and play that section here, you will notice that there is some options for me to add sensing and actuation. So here I just say actuation first law, but the idea here is that I just said that there is a motor attached to the system. So I can then say, I just have some blocks here to say that I have a constant block and an integrator block. So do take note, this is in the space of like meters per second or degrees per second or radians per second, right? So I'm trying to tell that particular revolute joint that you're moving on a certain rads per second. So when I integrate, I just put one here. Then when I press the play button, you would notice that I can actually move the wheel. So when I press the play button here, you would notice the wheel is now turning. So I just changed the view, right, or the left view, and the wheel is turning. Okay. So you would notice also in that particular setting is that there's a motion and torque is automatically computed. Just imagine yourself, you have a motor control. Definitely you have a PID controller for that. It's a closed loop system. So when you tell a system to run at 20 RPM, the PID or closed loop controller will tell you I'm going to run at 20. Right? No matter how much torque is required, but I will turn at 20. So this is like that kind of setting. So if you think about it, where I'm just controlling the motor to spin, right? But now what if I'm going to add in the motion model of that particular robot? And as what I mentioned, this is where you need to go back to your trigo, your algebra, your your fundamental mathematics, right? Because once you have all these things, I want to create the equation of the pose and the orientation. So if you think about it, as what I mentioned, what I want is I want to control the speed of the wheels, both wheels, and I want to understand its movements, right? I want to create a relationship between velocity of left wheel, velocity of right wheel, and its pose and orientation. So you would notice this is the typical equation of a differential drive system. Okay, because just imagine yourself, you have a differential drive system. Just a good idea is that if this wheel is at 20 RPM, right, and this is 15 RPM, so it means to say this one, I'm going to use red color, this one is faster compared to this one. So it means to say, oh, this one would travel faster compared to your right wheel. So it means to say this one would turn right. Okay, so you can control, actually, you can steer the system if this is the setup. So what if it's reversed? So it means to say this wheel is faster than this wheel. So it means to say it's going to turn left, right? So another thing, another case, if this wheel is equal, right, equal in velocity, then this wheel, this robot will move forward, right? If this wheel is, let's say, 10 RPM, and this wheel is running opposite 10 RPM, then this would be turning on its own axis. So with that kind of idea and concept, right, then you can build your equation. Okay, so the question now is, how do I come up with these equations, right? But generally, this is like how you would write it in the motion models, right? You start off with a graph. You start off that, okay, this actually has a certain points on the system on 3D space, and you need to model it, right? But as what I mentioned, there are already popular equations for certain robot models. So it can be a robotic arm, it can be a ground vehicle, it can be a car, it can be a motorcycle. This is already a given sets of equations, right? So in Simulink, what I did is I brought all these equations to Simulink, right? So if I move further, I still have my plant model from the CAD design, right? I know that I can control it through this block here, right? But I just added sensing. So just imagine it's a virtual sensor. I'm adding a virtual sensor, but in actual terms, this can be a tachometer. This can be a absolute encoder or something like that in actual vehicle, right? And the equation that you saw earlier is actually made into a Simulink block, right? So I just, let's say, place it here in this subsystem, right? So now I just have this planar joint to make it like this is my platform. This is my space that I want you to move left and right. So based on what I mentioned earlier, I want to, let's say, have a setup wherein everything is equal, right? And then the robot would move straight, right? What if now my wheel has a different setting, right? Left wheel and right wheel has the same value, but the other one is negative, so it turns at its own location, right? Next one is I just have like 0.5 and the other one is 1, and definitely it's going to turn left. Okay, so the idea here is really creating that motion models at the same time bringing in the information about the weight of the vehicle, the torque that I need to move the vehicle, and also its kinematics model. So once you have this platform, just take anything already. It can already do whatever you want to control without even buying that hardware, right? So because I'm already controlling it. The next thing that I can do is probably add in PID controllers, right? Because when you have your platform, let's say this is your robot, and this is part of your control systems, there's going to be like a feedback, right? And when we say we have our sensors, definitely we know that since we have the kinematics, right? F of velocity of our left wheel, velocity of our right wheel, the output of this one is basically our pose, X, the location, where is it in the X space, location in the Y space, in the Z space, but let's say a ground vehicle is always operating in a plane, so we don't need to go for elevation, right? And what we need is basically just the angle. So now I can create a system wherein maybe it's a closed loop controller that tells me if I can control VL and VR, I can actually change this one. So this is just another example wherein I added a PID controller, right? And you would notice like it's the same. I have a feedback of the angle. And then with the feedback of the angle, I just try to control it. Oh, can you move in pi by 4, pi by 2, pi by 3? So this is actually telling the robot to move in a certain space. This is just an example, but let's say you have a maze or a warehouse, and you want the robot to know from point A to point B, I have this path for you. Please follow it, right? And I just have that one, and then you would notice that it will follow that path where I am guiding or giving him a trajectory where and how to move to that directory using a PID controller. All right. So again, when you are developing a robot system, first things first is really you need to have that robot, right? So it's either you buy it or you create a simulation model of that robot. Now the question is, what's going to be your application? So this is one case of that application already, right? And I haven't talked about sizing of the motors already. Like when I say sizing, right? There's a ton of motors available out there in Alibaba or AliExpress or Mouser.com or Elements14.com. There's a lot of types of motors, but which one would you buy? Right? You're gonna just say, okay, I'm going to buy a 24-watt motor, right? Or I want to buy a big battery this size of battery, but your application is actually just 20 minutes or 30 minutes, not saying it's a one-day application, right? And this is where I think later on, once you use Simulink, this is where you can actually do sizing of that particular setup. So what about the Boston Dynamics spot robot, right? Because I just have here a very simple robot model. What about a difficult quadruple robot? So it's the same thing, but the difference is actually it's a bit more comprehensive to control, a bit complex to control, because you need to do what we call as gating. Gating means to say when you walk, right, you have a particular pattern on how you walk, and it's basically just a lookup table by default, or how people would develop it is a lookup table. And what you want to control is basically the, how is it? Your PID here is basically your center of gravity. You need to maintain that one, because if you're going to turn, it should be in the same setup. If you're going to like twist, right, or do certain things, then this one should be something that you will control, the center of gravity or center of mass of the system. So if, yeah, okay. So this is just an example of that. But the nice thing about Simulink is that you can bring in all this design setup, right? So this is the left leg, right leg, and then this is the gait face. So that's what I mentioned. This is like a human person walking, right? And definitely you have to record your pace, like your when you strike the floor, that's phase number 1. When you lift your feet above the floor, that's phase number 2, and so on and so forth, right? And when you are in Simulink, as what you've seen, there's like a power supply model. You can pretty much add in a battery model here to understand that, okay, I have the system, how long would it last? All right. Let's say it's a 4,000 milliampere battery. How long would it last? Right. And basically you can also add your let's say the movements of the wheel and also its gait positions. So this is the trajectory for that robot to move. So this is actually just, as what I mentioned, a lookup table, right? So that it follows that movements, right? So that it can, move forward or move backward. And again, you have the revolute joint, right? And also you will have the actuators, right? So you can then say, okay, I need this motor model or this motor specifications as well, right? And as what I mentioned, you also have a controller from here. So again, you don't really need to get like the actual robot itself. I think this is something that you can actually download on the website. So it means to say, if you want to have a spot simulation, you can just get this one from Mathworks website, and you can already create your applications. It might be a image processing application with the quadruple robot. It might be like a certain use case for that quadrupled robot. All right. So this is actually my last slide. But to think about it, we're just modeling on the platform, right? We know the kinematics equation of the robot. We know what sensors we have with the robot. We know how to control the motors of the robot, right? And now the next phase is actually to do some sensing, to do some complex perception of the environment, and also do probably planning and decision making. So for example, let's say you have a maze, then you want to go from point A to point B, and there's a lot of obstacle in the middle. So everything will come together, right? So sensing, perception, plan, design, and control. All right. And again, why you want to use this simulation tool. So as what I mentioned, right, there's really a lot of things that you need to simulate first. I just have the plant model of the robot, right? But generally speaking, you need to do some controls, right? I have an example there wherein you have PID control, but generally the robotic space, you need to probably go to like model predictive control, which is advanced controls, gain scheduling. You might go to reinforcement learning as well, if that's your research space, and then and you might want to add like applications for artificial intelligence as well. Okay. And I think Bang already mentioned about the campus-wide suite. So if you do have campus-wide suite license, everyone do have access to MATLAB and Simulink, right? And I'm not saying only one is going to use MATLAB and Simulink, only the electronics department is going to use MATLAB and Simulink. It can be your mechanical engineer, it can be your computer science students, it can be multiple students. Because if we go back here, right, on how to develop an actual robot, it's not only one discipline, actually. You have a discipline from the mechanics side. You have a discipline from electronic side. You have a discipline in your computer engineering and computer science, right? It's really like the combination of all those disciplines to come up with a robot. And here we're just talking about platform. It's heavily invested in terms of the mechanical engineering or electromechanical engineering. But after that, the next work is more towards computer science or computer engineering, right? If we go down to Ross, it's going to be a bit different. It's going to be on the communication side as well. So as what I mentioned, it's not about only one engineer who's going to use the tool, but it can be multiple engineers as well. And yeah, so I think I have some slides here to like go through a follow-up. And let's say if you want to learn more about MATLAB and Simulink, I can point you to this material here, MATLAB on ramps, so that you can get started. So especially for students who has just joined the session, you can actually go through this on-ramp sessions in MATLAB and Simulink. It's actually in my link inside the link in my slide, right? Then you can just click lunch, and from here in the MATLAB on-ramp or Simulink on-ramp, you can actually get a certificate. So if you finish this on-ramp sessions, right, on live setup, you can then maybe put it in your LinkedIn, or you can put it in your Facebook, or you can download it as a certificate, right? And you can get at least an idea on how to use MATLAB and Simulink. So that's just MATLAB on-ramp, right? But if you're into other topics as well, right? Simulink, circuit simulation, machine learning, deep learning, reinforcement learning, image processing, signal processing, SimScape, state flow, control design on them. These are free tutorials, so that you don't need to like, okay, where can I learn MATLAB and Simulink? It's here, and I think fundamentally you can start with this one, but after which I think you need to look for professors, or let's say someone that is really familiar with the tool, so that you can be more familiar with the tool itself. All right, so please go through the slide. I can actually just give you the resource Simulink models as well. But before that, I can check some questions, right? So I feel that it's all in Indonesian, bahasa Indonesia, but I'll try to.
Yeah.
Yes.
Okay, actually, thank you for your presentation. Yeah. So you already finish your slide, right?
Yep. Yes.
Oke, untuk teman-teman, jadi mungkin masih malu-malu nih dari penjelasan yang sudah di-share ke kita mengenai robotik dari Mr. Ian. Tadi ada satu pertanyaan mungkin yang saya share ke teman-teman sebelum kita lanjut. Mungkin bisa ada yang bantu saya untuk di ITS sendiri, CAD software-nya menggunakan apa ya? Jadi mungkin nanti kita bisa sesuaikan untuk next step-nya kalau memang mau coba step yang diberikan oleh Mr. Ian. Mungkin ada yang bisa bantu di kolom chat atau mungkin bisa jawab langsung ke saya. Ian, actually, for now I'm asking about their existing CAD software in ITS because you present with Solidworks, yeah.
Solidworks, yeah. Solidworks is one of the popular for students,
Yes.
but there is one. I actually use this one, so Onshape. So just to give you an idea, this is free. I'm not promoting Onshape, but how's it for students, right? Or let's say you're doing non-profit, maybe you can try Onshape, because I do have my own account here, because I do my own like 3D print. I do 3D printer things, right? I also have my design, so I created my own bike stand, that kind of stuff. But you can actually have this one. It's free, but the caveat or the cons of this one, since this is free, your designs are actually what we call exposed to the internet, so anyone can get it. Right. So for example, this is a CAD design of a cooker robot. So this is actually a cooker robot.
So I think the point is as long they can export to the STL file, right?
Yeah. So this one, you can see if I go share, right, then I can actually export this one. Like I can export to Simscape multi-body, right? Or if I close this one, I can actually save this one. So if I go here, let's see, I can save this whole thing as an STL file. So, but anyway, you can see, right, if I click share here, you can see like someone can just go Simscape multi-body and people can access it already. In MATLAB, we just need to copy paste this. Just to give you an idea, right? I have this design in Onshape. Maybe I have another design. Maybe look for another one. So probably like this servo motor, right? Like this is my design long time ago. I can copy this one, go to my MATLAB. I just go doc Onshape, just to give you an idea.
So this is the first step, yeah.
Yeah.
We get the 3D data.
So after you design this, generally you design this one in Onshape. This is generally like a CAD design tool, right? So once you have a CAD design tool, what I need is basically just how's it? This website, where is it being placed? Copy paste. Go to here. I'm just going to copy this one. Type in that. And go to here, copy paste this. Press enter. Then I think it will ask for my credentials in Onshape. Right? Give me a sec. Okay. Okay, so it's already confirmed that I have an account. Then it just brings in that data, right? So once it brings in the data, the next thing I need to do is, sec is loading. I need to import this one. So in my MATLAB right here, sorry, I then need to do an SM import. Click on that, SM import. Then this name. So once I have that one, this is my Simulink block of that robot model or whatever. So if I press the play button, this is your the design that I have earlier. Right. This is already in Simulink. So just again to give you an idea, you can bring in a design from somewhere and how's it? Create already your robot if you want to. Right. So there's no there's no there's no gap between I design something in a CAD environment and bring it to MATLAB. It's already here, right? And as what I mentioned, now I can control. Maybe I have some actuation, right? I have some sensing and so on and so forth.
Sorry, Ian.
Yep.
I think the important thing also, they have to build the 3D data with multi-body, right?
Not necessary. So this
necessary.
one is automatically built for you,
Wow.
right?
Yes.
So what I did is basically I have a design in a CAD environment, this one, right? And from the CAD environment, automatically all this information, how it's being connected, is actually from this XML file. So if I open this one, this XML file, this is actually the information how everything is connected. Okay, but it's like connected 1, connected 2, connected 3, that kind of stuff, that kind of setup. So I don't need to manually do that connection. It's already here. You can do that if you want to. Like, it's going to be very manual, but this is just an automation to bring that design in Simulink.
Yeah, because as a designer, maybe very difficult to design with the multi-body design.
Yeah, that's the first issue. Like I
Yes.
have a CAD design, but I want to do it in Simscape multi-body. Then I need to do it manually. Here it's a bit of a shortcut. So there's an automation tool to bring all these things in MATLAB.
Okay, yeah, and I think we can go to the first question. I think for this session we only have one question.
Yep, sure.
Oke, Ibu Nusifera ya? Sorry. Ibu Sawung Sari. She asking about this presentation. You will share this presentation?
Yeah, I will save the PDF file, the video files, and then you can do it on your own platform. Yep.
Okay, I think for another is only from Pak Basit. I think this is not question ya, Pak Basit ya. The only mention STL can be export from Google SketchUp and Autodesk Inventor too.
I think
Yes.
Autodesk Inventor, SketchUp, I'm not sure.
Yes, SketchUp also can
But,
export to STL.
How's it? We can check. So here, if I go to SM import, right? This is the ones that we support. Here, Autodesk Inventor, PTC. How's it? There are some limitations, but I think majority of the popular CAD designer is there. Also, it can be like URDF. I think for robotics, right, the most common is URDF. Just like the gazebo. If you're familiar with gazebo, the most common design or artifacts that they use is URDF files. Okay. Yep.
Oke, untuk teman-teman dari ITS, Bapak ataupun Ibu, ada lagi yang ingin ditanyakan sebelum kita akhiri, karena mungkin sesuai dengan schedule kita sudah lebih dari 4 menit ya untuk sesi pertama ini. Boleh di-share ke chat kalau memang masih ada. Karena mungkin kita akan coba lanjutkan untuk sesi kedua ini di minggu depan di jam yang sama. Tanggal 24 di jam yang sama, jam 2 waktu Indonesia Barat. Ada yang bisa bantu saya mungkin di sini dari perwakilan host di ITS?
Iya.
Ya, Bu Dini, terima kasih.
Memang. Sepertinya sudah jam 3 ya. Mohon maaf, ini tadi saya disambi.
Oh iya, nggak apa-apa, Ibu.
Ya, untuk materi nanti akan di-share.
Betul.
Di linknya begitu. Kemudian nanti bisa mencoba begitu ya Pak ya.
Iya.
Untuk demonya. Thank you Mr. Ian.
Jadi mungkin tapi Bu Dini ini sepertinya masih pada malu-malu ya. Sesi pertama ini mudah-mudahan nanti sesi kedua nggak malu-malu lagi.
Ini ada pertanyaan ini Pak. Ada hand.
So
Dari
don't forget for the next 2 episodes for that
Yes.
next week. Yeah.
Oke,
Yes,
Pak
Mr.
Ardi ya.
Ian. Ya, silakan Pak Ardi atau Mas Ardi, silakan.
Yeah, thank you very much. Hello, Mr. Ian. My
Yep.
name is Ardi.
Hi, RD. Yeah.
Your presentation is amazing.
Wow. Congratulations, Ian.
Newbie for Simulink. So I just want to ask some questions because I'm graduated from mechanical engineering, but I don't know how to make coding, something like that.
Yes.
So my question is, I interested that you share that there is Simulink can connect with AI, artificial intelligence.
Yeah.
Since we can control our robot with AI, so I think it could be a smart robot since they can learn from their mistake or something like that.
Yep.
So question is how to connect Simulink with AI, because it's quite interesting.
Yep.
Yes.
So let
That's
me
all.
share my
Thank
screen
you.
again. Right.
Yeah,
So
thank you.
how is it? Normally, generally that particular topic is more towards what we call as reinforcement learning or deep learning, right? So in MATLAB and Simulink, I'm just going to go reinforcement learning here, reinforcement okay. And I'm just going to go to examples. And if you're familiar with reinforcement learning, this is like controls, but instead of using MPC or PID, right? We are going to change that usual control system into a a agent or a artificial intelligence. So that's actually one. So you would notice there's a example in MATLAB and Simulink, quadrupled robot using DDPG agent, or biped robot walk using reinforcement learning agents, right? You would also notice like there's a lot of adaptive cross control, there's lane keep assist. These are pretty much AI specific platform already. But if you think about it, there are usually using what we call as blocks. So if I go to Simulink here, right? And let's say if I just, I can just go to like deep learning. That's the most common one, right? And I go to examples in, in Simulink, right? So there's 17 examples, but that's heavily, okay. So you can see there's like lane and vehicle detection using deep learning using our tools, right? So if I click on this, right, these examples, this is actually in Simulink environment. So as what I mentioned, if you are able to bring in a robot model or any physical models in Simulink, then there's actually a lot of opportunities for you to bring in controls, image processing, computer vision, or whatever it is. Because once you have it, we do have like blocks already available for you, right? And this is where you can actually have a mathematical model or a deep learning model or whatever models that you have, and then bring it to Simulink and do your simulations. And the nice thing about the latest release of MATLAB and Simulink, just to give you an idea, is that we can actually connect to third-party simulators. So when I say third-party simulators, right, if I just go to an example here, if I go to documentation and I click on, let's say, vehicle dynamics block set. Where's it? Vehicle dynamics block set. We do have opportunity to connect to third-party scenarios. So for example, this one, you can get like connection to Unreal Engine, right? If I go to robotics or ROS toolbox, this is where we can actually connect to your gazebo. So this is something that you can, let's say, have a simulation of a robot at the same time, gazebo environment. But again, for me, you can start with some references, and again, we do have a lot of examples wherein you have Simulink, you have that AI component, and then you can just bring it in, right? So yeah, so this is some of our examples, right? So like this is an example of using Simulink, right? So there's a gazebo environment, but we're controlling the robot in Simulink. Okay, did I answer your question?
Okay, thank you.
Okay.
Thank you very much for your detailed explanation.
But I think you need to try it out. So
Yes.
again, it depends on the applications, right? So you can see it's actually doing like sign following. So there's an image processing use case for that. But as what I mentioned, it's a model, right? So if I go open this live script and open that model, so this is actually the model. Right? So if I open the model up, you will notice there's a component of the image processing algorithm. And there's also, because I'm using ROS here in the sample, so we're actually sending commands to the ROS environment. So if I increase the size, so you can see we can bring in ROS data, we can bring in the odometer data, then we can command the velocity through ROS, then you have this image processing component here. Okay. Yep. So there's another one who raised his hand.
Yes, Mr. Ronnie.
Okay,
Mr.
thank
Ronnie.
you. Yeah, I'm sorry, I have a 2 meeting here today, so sometimes I miss. So I have a question. In ROS, there is a very famous capability of ROS that it's support for the multiple machine. So ROS is support for multiple machines. So if I have so many machines that it can be connected together. So is it MATLAB support also for that kind of can be connected on multiple machine? Okay, thank you.
Yeah. So by right, yes. So when we talk about ROS, that's going to be in the next episode. But to be in advance, there are two things that the ROS can do. So one is actually prototype. One is actually we can deploy the ROS, right? So when we say prototype means to say I can run it in MATLAB, but I need to specify the IP address. So when we say ROS setup, right, it's by an IP address. So if you have another robot, that's going to be an IP address 192.168.1.2. Then maybe there's another robot that's 192.168.1.3. So that's where you can actually control the robot and prototype on it. So when you say prototype, my MATLAB is running together with that robot. But another feature that we have is that we can actually generate C and C++ code, right? And deploy that ROS node to a ROS compliant hardware. So an example, if I go back to some examples here, is that we do have examples here to deploy as well to let's say a Raspberry Pi, NVIDIA Jetson. So if I go to you can see, let's see if there's a example for Raspberry Pi here. No. But anyway, so you would notice that we can generate the node, right? And when I say generate the node, right, we can actually bring that algorithm to a ROS compliant hardware. And that's something that is really good with MATLAB and Simulink, since you're not just stuck with your development computer, but your algorithm, whatever you have written, maybe this algorithm here, I can bring all these things to a Raspberry Pi.
Sorry,
Right.
I have to stop.
Yeah. Yep.
I think for ROS, we have the agenda for season
Next
3.
week. Yes, it is.
Sorry, Pak Roni. So I think for detailed information for ROS, I think we can continue for
Next
the
week.
system. Biar penasaran, Pak. Sorry.
Okay, thank you.
Ya.
Thank you.
Terima kasih, Pak Roni. Ada lagi mungkin yang mau bertanya, raise hand, silakan. Ini baru angetnya baru belakang-belakangan nih Bu Dini.
Iya Pak.
Iya.
Jadi pemanasan.
Lagi pemanasan ya, aduh. Jadi mungkin ada lagi sebelum kita akhiri. Ini mulai memanas, harusnya sudah ada mulai banyak pertanyaan nih. Jadi untuk slide presentasi serta link demonya nanti mungkin kita share ke Bu Dini dulu ya. Nanti Bu Dini bisa bantu share.
Iya. Baik Pak. Terima kasih.
Ada lagi Bapak atau Ibu? Dalam bahasa juga mungkin boleh nanti dibantu oleh Mr. Ian, you can speak bahasa, right?
No.
Mungkin ada lagi sebelum kita akhiri? Kalau tidak, mungkin gimana Bu Dini untuk sesi pertama?
Sudah dicukupkan ya Pak. Sudah.
Iya. Jadi mungkin sebelum kita akhiri, serunya mungkin kita bikin sesi foto dulu ya Bu Dini untuk kenang-kenangan nih. Karena lumayan cukup banyak nih. Tadi dari 86 lebih sekarang udah mulai turun. Sebelum makin turun lagi nih.
Betul.
And I think before we end the session, we want to take a picture first.
Yep, sure.
Oke. Oke, Riwan. Pasang muka paling ganteng dan cantiknya, Pak. Atau Ibu. Jadi mungkin
untuk menyalakan kamera Bapak Ibu dan
buat kenang-kenangan saya nih.
Udah
Kenalan dengan teman-teman dari IPS. Walaupun masih ada 2 sesi lagi kita nanti. Oke. Mungkin Pak Ardi bisa dinyalakan. Ini mungkin tidak bisa langsung semua, nggak apa-apa ya. Ini mau dari Bu Dini atau dari saya?
Boleh Pak, dari saya hitung ya.
Oh, silakan. Iya.
Oke. Baik Bapak Ibu, saya hitung 1, 2, 3. Ada 2 slide?
Silakan.
1, 2, 3. Ya, terima kasih.
Iya, terima kasih. Terima kasih Bu Dini untuk waktunya dan terima kasih untuk kesempatannya juga yang diberikan kepada kami. Jadi mungkin kita akan lanjutkan untuk sesi kedua di minggu depan ya Bu Dini, di waktu yang sama seperti itu.
Ya, terima kasih Pak Bambang. Thank you Mr. Ian for the sharing.
Sehat-sehat untuk semuanya.
See you next week.
Iya.
See you next week.
Terima kasih
Guys.
Bapak Ibu semuanya.
Iya, terima kasih.
Keep safe and healthy.
Iya,
Selamat
bye.
siang. Selamat sore, bye. Assalamualaikum warahmatullahi wabarakatuh.